Alright, Assalamualaikum everyone. Welcome to lesson number 4 on basics of nomenclature. Today we will be looking at another homologous series which are alcohols. So as always we will go over our rules. The only rules that you need to know for this video is to count to count the longest consecutive carbon chain, to decide the prefix, look at the functional group to decide the suffix. Now in this case, remember that in whichever molecule you see a COH bond, so we call this thing right over here as a hydroxyl group. So wherever you find this hydroxyl group attached to a carbon, we call it as an alcohol. Now the suffix for our alcohols is anol. So for example, if you have one carbon, the prefix will be meth, and then because we are imagining an OH bond in there, so it will end with anol, so it is going to become methanol. If you have let's say two carbons, so it's going to be eth, and then you will have the suffix anol, so it will become ethanol, and so on and so forth. Methanol, ethanol, propanol, butanol, pentanol, and you can go on and on and on as long as you know the prefix, which at this level up till your 10 carbons is enough. So up till decane you are more than fine to go. All right, and then we have the carbon, as we have already said, the carbon with which, not the X in this case. In this case we are talking about our OH group. So with whichever carbon this OH group is attached, you will give it the highest priority, which means when you are numbering this carbon chain, you will try to number this carbon with which OH is attached, to somehow have the lowest possible number. So let's do a few examples. In this particular case, I've included some skeletal formulas as well, and that's because I want you to become more and more familiar with skeletal formulas even at the AS level, because in A2 all you're going to see are these weird structures, and so it's better or best to have these down and deep rooted in your brain by the time you hit that level. All right, so coming to the first example, I can see that I have a two carbon chain and I have a OH group attached. And so very simply, I know that the name is going to start with eth. And now, because I only see an OH bond, you can say I see a hydroxyl group attached to a carbon, I will end it with anol, and there you go. That's your name. It's called ethanol, a very famous alcohol indeed. Now let's come to case number 2. In this case, I see 1, 2, 3, 4, and 5 carbons, and so let's decide our prefix, and that is going to be pent. And now, because I see I see a OH group attached over here, I can call it as pentanol. But ask yourself if calling it pentanol is going to be enough for a person who is reading this name to know exactly where that OH group is attached. Remember, the key to nomenclature is that whatever name that I've given this molecule, is it enough that if anyone comes up and reads only this, knows exactly or has a one-to-one mapping of what kind of a molecule am I talking about. Now, in the case of pentanol, you can have your OH group over here, but you can also have your OH group over here. You can even have it over here, right? So where exactly is that OH group attached? Yes, I get that there are 5 carbons and there's an alcohol group involved, but where exactly is that OH group attached? And so for that, we first need to number our chain. Now, doesn't matter, you can number it from either side. You'll see that you will end up with this carbon being labeled or numbered as 3. Now, in the case of alcohols, the case is kind of very similar to alkenes. So alcohols and alkenes kind of have a very similar kind of a naming, and the reason that I say this is because we take this anol, all right, we separate it, we actually separate it from the pent, and what we do then is that actually wait a minute, what we do instead is that we take this all right, let me grab this all, put it over here. All right, so what you do is you break the name by taking the all and the an, and you put them on, you create a space between them. All right, and what you do is that in the middle you add this number which is going to indicate where the alcohol group is attached, so it will become pentan 3 all. And as weird as it sounds, this is how you actually name it. So pentane or I would say it's pentane 3 all, but I don't know why I was saying pentan, whatever. Okay, so pentane 3 all. Okay, and what you're doing is you're separating the an and the ol, and you're inserting the name in between. So this is very similar to saying but to ene, or saying but one ene. So that's why I said that we kind of do the same thing in alcohols as we do in alkenes. So we call it as pentane 3 all. So this tells us that our OH group is attached on the third carbon. Let's do another example, and perhaps it is going to make more sense. So over here, we have 1, 2, 3, 4. Okay, you know what I'm going to do in this case? Let me kind of like expand this, so that the image of this molecule becomes more clear in your head, because you might get misguided on what I'm about to do here. So whenever you have this CH32 attached with a carbon, what this is telling is that you have two methyl groups attached to this carbon. Okay, this bracket sign and a 2 outside this is telling you that this you have two methyl groups attached to this carbon. And if you are to do that, this is something how you will do it. You have an OH group here, you have a CH3 here, and then you have a CH3 here. Okay, and so now that I've made this expanded structure of this molecule, you can see that in the longest carbon chain, you can only have 4 carbons. And that, although I was about to do that directly, I didn't do it because I just realized that some of you may get confused and think that, oh, well, you had 5 carbons over here. So 2 sign. So 2 carbons, 3, 4, and 5. So I didn't want you to get confused. So I've drawn out the bigger image of this molecule, and I hope it makes sense why I said that there are only going to be 4 carbons in the longest carbon chain. Let me actually draw it, this somewhere over here so that I can name the molecule as well. So now that you have this expanded version of the molecule, I hope the naming won't be an issue now. So we have 4 carbons in the longest carbon chain, so it will be but. And apart from that, because there's an alcohol group attached, remember from my previous video that our OH group is given higher precedence than our alkyls, right? So you can forget about the alkyl group for now. Let's quickly number this. This is 1, 2, 3, and 4. And so what I will do is I'm going to write butan, and then I'm going to write 2, and I'm going to write all. So for now, this has basically, butan to all has basically is enough for this part. All right, but remember that you have a methyl group as well. We can't ignore it. We definitely don't give it as much importance as the hydroxyl group, but we can't ignore it in the naming. So now that we are done with butan 2 all, I'm going to take this CH3 group and I'm going to name it before it. So I'm going to say 2 methyl butan to all. So this is the way that we actually name our alcohols which have a methyl or an alkyl group involved along with a hydroxyl group involved. Okay. In case of any confusions, do write them in the comments below, and I'll try to explain or answer those queries as well as I can. But as far as this video goes, I hope you are up till this point understanding and getting the concepts that I'm trying to give you. Okay, let's move on now. Now this is a very, the last two examples are going to become very interesting, because now this is a skeletal formula, and in the skeletal formula, remember that every vertex is a carbon. All right, and we don't show the CH bonds, we only show the CC bonds. CC is like the spine, the skeleton, and then we add in a few lines here and there and add functional groups and all of that. So remember that every every vertex is a carbon. So in this case, you can see you have 1, 2, 3, 4, 5, and 6 carbons in your longest carbon chain. And so I will name this as hex. Now I can clearly see, okay, now one very important thing, if you ever in a skeletal formula you see a line, all right, and you don't see anything over here, all right, you don't see anything over here, you just see a line, this is always going to be methyl. Now, this is a very important thing that some people sometimes overlook, especially when they're new to new to skeleton formulas. So the skeletal formula, sorry. So I'll make this over here. Whenever you see something like, whenever you see something like this, okay. Whenever you see something like this, just a line, this thing right over here. This is what we call as methyl. This is a methyl. So there's a CH3 group attached here. We're not showing that because we don't show our carbons and hydrogens. We just draw lines between carbons. So remember, this is always going to be a methyl. And if at any point you see something like this, so you have this and this and this and this, and then you have, let's say, this and this. Now this thing right over here is it's an ethyl. Why? Because this is going to be one carbon and this is the other carbon. This is CH3 and this thing right here is CH2. So this is actually an ethyl group. So I hope you can like make sense of this at least. All right, and if you can't make sense of this, then I would like recommend you to go watch our video on the different types of formulas that exist in organic chemistry, and over there we have gone over some of the examples where we have tried converting our skeletal formulas into display formulas and vice versa. So I would definitely recommend watching that video if you can't really realize what's happening over here. All right, so because we give our OH or our hydroxyl group more preference over our alkyls, I will forget about the methyls for now and I will name my alcohol as it is. So in this case, let me number this. So this is first, second, third, fourth, fifth, and sixth. And so now I know this will become hex 1. My bad. I can't write, we don't write hex 1 and all. We write this as hexane 1 all. Okay, so this is hexane 1 all. All right, now remember that what you see over here are two similar groups. You have two methyl groups. So what do we do in this case? I hope you can recall that we use the Greek numerics over here and we will call this as dimethyl. And when we're calling this as dimethyl, it tells the reader that there are two methyl groups in this molecule, but then we need to specify where exactly are these located. And if you look at the numbering that we have done, we have one on 3 and the other on 5. And so the name is 3,5-dimethyl hexane 1 all. Alright, now let's go to the last example. This one is a bit easier if you have understood our last example very well. So over here you can see I have one carbon, second carbon, third, perhaps let me use the vertex. Yeah, that will be easier for you guys. So one carbon here, second here, third here, fourth here, fifth here, sixth here, seventh here. So every vertex is a carbon. Remember that. Vertex are basically these dots that I've made over here. All right. So this thing right here, because there are almost 7 carbons, 1, 2, 3, 4, 5, 6, 7. Yes. So this is going to be hept. Now I know it has a OH group attached, so it's going to be heptane something all. Now this something is basically the numbering. So let me number this from this side so that my carbon with which the OH is attached gets the highest preference. So this will become heptane 3 all. Why? Because the carbon with which OH is attached is number 3 basically. And now you can see that you have this methyl group attached as well. And so we will name that, and this will become as 6-methyl heptane 3 all. Why 6? Because it is on the 6th carbon with which this methyl group is attached. So this was the naming for alcohols. I tried to gradually build up on the example. So we did a very simple example first, and then we did an example where the OH group is attached somewhere in the middle, and then we did an example where we had methyl groups involved as well, and then eventually like multiple methyl groups involved in question number 4, and question number 5 is kind of a simpler version of question number 4. Nonetheless, I hope they made sense to you. If yes, then give this video a big thumbs up, subscribe to the channel, and hit the bell icon. In case of any queries, put them down in the comments below, and I will make sure to answer them to the best of my abilities. If you have any questions about our ongoing tutoring sessions, you can always DM us on Instagram channel. We are always offering one-on-one sessions to most of our students for most of the subjects for O and A level both. So in case of that, if you require one-on-one tutoring, you can also once again use our Instagram handle below and DM us about what is that you are basically looking for, and what is it that you want to cover and stuff like that, and we will definitely get back to you. So I'll see you next time. Take care.